Alright, so today we're going to look at metric prefixes and how to convert measurements from one unit to another using a process called dimensional analysis. Before we do that, let's talk about conversion factors for a minute though. We all know what conversion factors are. They're just numerical equivalencies that allow us to convert from one unit to another. So we could list off hundreds of these that we already know. We could say there's 24 hours in one day. Or we could say there are 52 weeks in 1 year. Or we could say there are 5,280 feet in 1 mile. We could say there are 3 feet in 1 yard. And we could go on and on and on. But you notice the majority of the units I used over here, like miles, feet, inches, and so forth, they don't fall into the SI system of measurement. They are the American Standard System. So before we look at conversions with these factors, let's look at the metric system and the prefix system that's used for those conversions. So you've probably all seen this little, whatever you want to call it, line of letters before. And you probably have some little rhyme or saying to remember it. Well, let's go through and refresh ourselves on what it means. So the K stands for kilo. The H and the DA stand for hecta and deca. We really don't use those, so we can put an X under those. We leave them there though for placeholders so we know how many places to move. U stands for units. So that's really just the base unit. So I'll write units and then I'll write base. So this D is the one we commonly use. It is deci. C stands for centi. M stands for milli. Then we skip to, and this Greek letter mu stands for micro. When you see it typed a lot, you'll see it typed as a lowercase u because it's easier to type, but that's the way you write it. Then N, after you skip 2 more places, stands for nano. Then back up in the other direction, we have mega, and then we have giga. Notice there are 2 places between kilo and mega, and 2 places between mega and giga. So then we have the conversion factors that correspond to these prefixes. So I'm going to write them as powers of the number 10. So for units, I'm going to write 10 to the 0 power. Okay, so for deci, I'll write 10 to the negative 1. For centi, I'll write 10 to the negative 2. For milli, 10 to the negative 3. For micro, 10 to the negative 6. Nano, 10 to the negative 9. Okay, so then I would have 10 to the 1. 10 to the 2nd power, 10 to the 3rd power, 10 to the 6th power, 10 to the 9th power. So you could also write this as 1, because 10 to the 0 is 1. You could write it as 0.1, 0.01. You could write that as 10, 100, and so forth. But when you get to this area down here where you have 9 zeros on either side, it's easy to write in scientific notation. So most of the time, we'll stay in this range right here. The times that you see mega and giga in your day-to-day life or dealing with computers, you see gigabytes and megabytes. So usually, the conversion normally used is 1 byte is about equal to 1 character on a computer. So a gigabyte is 10 raised to the 9th power characters, or megabyte is 10 raised to the 6th power characters. So this is something you need to be very familiar with. And you also need to know these conversion numbers at the top. So I know you've probably done this before, and you've done the thing where you put your pen on kilo and you move it, 4 places to get to centi, or however many places that is, and then you find your number and you move the decimal the same number of places, and that works. But hopefully at this point in your academic career, you're a little bit beyond that. So we aren't going to do that anymore, hopefully. We're going to use a process called dimensional analysis for converting from one unit to another. So all dimensional analysis is a process that we use to convert a number from one unit to a different set of units. So we're going to do it quite a bit here in this chapter, and a lot of times we'll do it in situations that really don't even apply to chemistry. The reason we do it now is we do dimensional analysis again after Christmas, doing what we call stoichiometry, which is one of the most central ideas of chemistry. So we learn it now, the process of dimensional analysis, we learn it now doing easier type problems so that when we apply it to more difficult situations later on, you already know how to do it. So rather than listing out a bunch of steps for completing dimensional analysis, we're just going to jump in and solve a couple of problems, and hopefully you can learn while doing here. There are 2 rules that we have typed out in the notes that I think are important that you write down just so you remember it. The first is that you always put a 1 beside the unit with a prefix on it. So always put a 1 beside the unit with a prefix on it. And then the last step is to always go back and cancel your units. Okay? So we're going to go through some problems. There is a slightly different way that you can solve these and get the same answer, but this is the method I prefer, so we'll go with this. So let's look at a problem. Let's just say I want to convert 100 centimeters into meters. Okay, so I can write that into words. I can say, how many meters are in 100 centimeters, but we'll abbreviate like that. So the first step is always going to be to write what I'm given in the problem. 100 centimeters. Then I draw this little box thing, and you may have seen this before. Then you always take the units that you start with and drop them down. Okay. Then I put the units that I'm trying to go to on top. Okay. So now I have to come up with a conversion factor to convert from centimeters to meters. In order for me to be able to multiply 100 by some numbers and still have a valid answer, this has to be equal to 1. So the numerator and denominator have to be equal, just with different units. So if I go back up here to my little table, I see that centi is associated with 10 to the negative 2. Okay? And I remember what I just wrote down, that I always put a 1 beside the number with a prefix. So I put a 1 beside the number with a prefix, and then I put a 10 to the negative 2, okay, beside meters. So this number, 10 to the negative 2, I got because of the centimeter, but I put it beside the meter. So you always want to flip that, and hopefully you'll get used to it after a couple of problems. So then, I think I'm done. Okay, I think I've done what I needed to. Let's go back and check ourselves though. Centimeters, cancel centimeters. I'm left with meters. That's what I tried to get to. So I know I've done it correctly. So now you multiply across the top. So 100 times 10 to the negative 2 is just going to give me 1. And then you divide by what's on the bottom. So 1 divided by 1 is 1 meter. And that's my answer. Could you have gotten that in your head? Most likely. Could you have done it moving the decimal place? Definitely. But again, we learn this process now so we can practice it, so we get good at it, so in a couple of months it's not anything new to you. Okay, so bear with me. I know you don't want to do it like this, but do it this way for now. So let's look at another one. Let's say 3 kilometers is how many meters? So notice I used meter here both times for my base unit. I could have used seconds. I could have used any of the SI base units there, so we'll change it up here in just a second. So here, the same process. I want to copy what I'm given in the problem. 3 kilometers. Before I even know my next step, I automatically know I'm going to drop these units down here. What I have goes on bottom. What I need goes on top. So I have kilometers. I need meters. Okay. So now I go up to my chart. I see kilo corresponds to 10 to the third power. But I know I always put a 1 beside the number with a prefix. So I write 10 to the third beside meters. I go back. I know it seems simple with only one step, but these problems will get very long 7 or 8 steps later. So we go back and cancel the units and check ourselves. Kilometers cancels kilometers. You're left with meters, which is what I asked for. So 3 times 10 to the third meters is my answer. Okay. So now let's try one. Let's do seconds this time. So I have 0.002 ks, which is just a kilosecond, and I want to convert that to milliseconds. Okay, ms. So you can go straight from one prefix to another prefix. That can be done, but I prefer to go from a prefix to the base unit, and then from that base unit to the other prefix. So let's see what that looks like. So let's start with what we're originally given, 0.002 kiloseconds. These units automatically get dropped down here. Then, rather than going straight from kiloseconds to milliseconds, I want to go to seconds. What I'm trying to go to goes on top. So I go up to kilo, I see it's 10 to the third power, and you can look at your paper now, this is something you need to have memorized eventually. But I know that 1 goes beside the prefix, so I put 10 to the third power here. Now I just add another little box. You of course could go ahead and get that answer in a calculator and do a whole separate problem. There's no point in that. We can just continue this problem here. I drop these units down here, seconds goes down here. Now I'm trying to go to milliseconds. That goes up here. Milli corresponds to 10 to the negative 3. I always put a 1 beside the number with a prefix. So now I have 10 to the negative 3 here. So now I'm ready to go back and double check myself. I have kiloseconds cancels kiloseconds. Seconds cancels seconds. If one's in the numerator and one's in the denominator, it cancels. And I'm left with milliseconds. So go ahead and type that in your calculator. The way you'll do it is 0.002 times 10 to the third divided by 10 to the negative third. Okay, so when you type that in, you should get 2,000 or 2 times 10 to the third milliseconds. Okay. So I know I told you in a previous video that any calculations we did, we would have to use the rules for significant digits and follow the correct guidelines for that. But conversion factors do not have significant digits. Okay? Significant digits only occur when we take measurements. So the original numbers will have significant digits. Okay, so we have one significant digit here, one significant digit here, one significant digit here. So we keep 1, 1, and 1. So we only look at the original number given in the problem for our significant digits. We don't consider any of the conversion factors there. So let's look at one more of these metric conversions here. So let's look at, let's just say 100,000. We'll say micrograms. And I want to convert that to, we'll just say kilograms. Okay. So I always write what I have to begin with. So 100,000 micrograms. I draw my little box. These units automatically go on bottom. I don't want to go straight from micrograms to kilograms. I want to go from micrograms to grams. So grams goes on top. In the next step, I drop grams down to the bottom because now I'm trying to cancel grams. Then I want to go to kilograms. So kilograms goes on top. So what I already have, I put on bottom to cancel it. What I need, I put on top. That's what I'm trying to ultimately get. So now go back and add your conversion factors. You could do this as you go, but I like to go ahead and put all my units in, then go back in and add my conversion factors. So the number that corresponds to micro is 10 to the negative 6th. but we always put a 1 beside the number with a prefix. The number that corresponds to kilograms is 10 to the third, but we always put a 1 beside the number with a prefix. So now go and type that in the calculator, which I believe should be a heading in your notes. So the only difference with metric versus non-metric conversions, when we're doing non-metric conversions, we have to know the conversion factors. Okay, we can't pull the 10 to the third or 10 to the second from that little table. So let's just ask ourselves, let's say we have 1 mile, and I want to know how many inches are in a mile. So I want to convert from 1 mile to inches. So again, the same process. I just write down what I have to start with. It's best not to abbreviate mile and meter. Tend to get confused if you abbreviate mile, MI or M. So let's just write it out. 1 mile. I drop those units down here automatically. 1 mile. But the problem is I don't know a conversion factor to go straight from mile to inches. At least I don't. You might. So we're going to go with what we know. We do know the conversion factor from mile to feet though. And then I know the conversion factor from feet to inches. So there are 5,280 feet in 1 mile, and there are 12 inches in 1 foot. Sometimes people accidentally flip these numbers. So read it to yourself. You should be able to read each step as there are 12 inches in 1 foot. If you flip it, accidentally it would say there are 1 inch in 12 feet, and you should catch that as being wrong. So then you can type this in your calculator. 1 times 5,280 times 12. So you should get 316,800, but originally I only had 1 significant digit. So for my answer here, I'll just write 300,000. Or I should probably write that in scientific notation. So 3 times 10 to the 5th power inches. Okay. I know this seems a little strange to round off that much. It's just because the example you were given only had 1 significant digit. Okay. So let's try another example. Let's ask, how many minutes are in a day? Let's say 2 days. Just change it up. So 2 days, and I want to convert that to minutes. Okay. So I write what I have to start. So 2 days. I drop the units of days down here. I can't go straight from days to minutes because I don't know that conversion factor. To go straight from one thing to another, I have to know a conversion factor. But I can convert from days to hours. I do know that. Then I can convert from hours to minutes. Okay, so there are 24 hours in 1 day. There are 60 minutes in 1 hour. I just realized I forgot up here. You should always go back and cancel your units. Miles cancels miles, feet cancels feet, you're left with inches. So now, back down here, read these conversion factors to yourself. Make sure you didn't flip them. There are 24 hours in 1 day. There are 60 minutes in 1 hour. So we're good. We can type that in the calculator now. 2 times 24 times 60, and you get 2,880. But we need to round that to 1 significant digit, so we get 3,000 minutes. And I know using these concepts we're familiar to, time and distance, the significant digit rounding again seems strange, but bear with me. It'll make more sense when we apply it to chemistry problems. So go back and check yourself. Days, days, hours, hours, minutes. Okay? So let's look at one more of these. Let's say, I'll give you one to try. Let's say 1 mile is how many centimeters? And I'll change that to 1.00 miles. Okay. So go ahead and try that on your own. 1 that should be 1 mile is how many centimeters. And I will tell you there are 2.54 centimeters in 1 inch. So go ahead and pause the video and try and solve that one on your own. Alright, so hopefully you got 161,000. So let's go through it in case you didn't. You have 1 mile, you drop the units of miles down here, and sorry, I keep making that plural. You want to go from miles to feet, because I know that conversion factor. I don't know a conversion factor to go straight from miles to centimeters, but I do know there are 5,280 feet in 1 mile, so put feet on top. Then I want to cancel feet, so I drop feet down here. I can go from feet to inches, I can go from inches to centimeters. Then I take a second, go back and read the conversion factors myself. 12 inches in a foot, 5,280 feet in a mile, so I'm good there. Go back and double check my units, miles, miles, feet, feet, inches, inches, centimeters, so I'm good there. And the last thing to check, there are 3 significant digits, 3 significant digits. Okay? So hopefully it's not too difficult. There are quite a few more practice problems in the notes that we'll look at. So go ahead and look at those problems now. I'll tell you in class which ones to look at, but we're going to go ahead with the notes and look at some problems that are a little bit more challenging. So the next thing we want to look at are cubed and squared units. So I might have something like when, just say, cubic foot is equal to how many cubic inches. So same basic process here. I can say 1 foot, that's 1 cubic foot, apologize. And then I drop cubic feet down here. And then the same thing, cubic inches up here. Okay. I know a conversion factor to go from feet to inches, but how does that being cubed change it? Well, when you cube your units, all you have to do is cube the conversion factors. So 1 foot cubed doesn't change anything. 1 to the 3rd power is 1, but 12 raised to the 3rd power does change it. Okay? So I have 12 raised to the 3rd power. So now in the calculator, I can type that in, 12 to the 3rd times 1, and I get 1,728. So I have about 2,000 cubic inches. Okay, so nothing different. It's the exact same process. You just can't forget to cube or square your conversion factors if your units are cubed or squared. So let's look at one more. Let's say 12.5 square meters is equal to how many square kilometers? Okay, so I have 12.5 meters squared. I drop that unit down automatically, meters squared, and I can go from meters to kilometers. So I know that, sorry I slid that up, I know the conversion factor that corresponds to kilometers is 10 to the 3rd power. And I know I put a 1 beside the number with, or excuse me, the unit with a prefix, but then I have to square my conversion factors. Okay? So then I will multiply across the top and divide by what's on the bottom here. At least when you type that in, hopefully you get 1.25 times 10 to the negative 5th square kilometers. And you should know that when you raise a number with an exponent to another power, you multiply the exponents together. So this down here is equivalent to 10 to the 6th power. Okay? So nothing new here. Just be sure that if you have a cubed or a squared unit, you go ahead and cube or square your conversion factor. So now we want to look at ones that are a little bit more challenging. Let's look at the derived unit conversions. So that might look something like meters per second. We'll start off easy, to meters per hour. Okay, so I can just say 12 meters per second. I want to convert that to meters per hour. So a little bit different here. I start off the same way, 12 meters, but it's over seconds. So it's 12 meters over 1 second. So you can leave off that 1 there and just have 12 meters over second if you want to. That's perfectly fine. So now there's no need for me to drop this unit of meters down here because I have meters on top. That's where I need for it to stay. But I have to cancel this unit of seconds. So if it's already on bottom and I want to cancel it, I need to put it on the top. So it's a little bit different when it starts in the denominator. So seconds. I need a conversion factor to go from seconds to hours. We likely know that, but let's go ahead and go from seconds to minutes, just so you can see what's going on a little more. Okay. So now I have minutes in the denominator. It's not quite where I need to be, but I'm closer. I still need to cancel out the minutes. Minutes on top, hours on bottom. So now I can say there are 60 seconds in 1 minute, 60 minutes in 1 hour. So before I type this in, let's check it. Seconds cancels seconds, minutes cancels minutes. So I'm left with meters per hour, which is what I ultimately was trying to accomplish, meters per hour, so I'm on the right track. So I'll do 12 times 60 times 60, and with 2 significant digits, you should get around 43,000. Okay, and my units are, I ran out of room, meters over hours. Okay, so let's look at another one of those. Go ahead, after I write this one down, you can pause the video and you can try this one. So let's say 15 yards per minute. Now I want to convert that to yards per day. So go ahead and pause the video and try to convert from 15 yards per minute, so you're traveling 15 yards per minute, convert that to yards per day. So hopefully you got about 2,200 yards per day. So let's talk through it. I had 15 yards over minutes. I needed to cancel minutes, so minutes went on top. Then I needed to go from minutes to hours, so hours is down here. Hours needed to be canceled, so it goes back on top, then hours per day. So let's go back and check my conversion factors. There are 24 hours in 1 day. There are 60 minutes in 1 hour, so we're good there. Let's cancel our units. Minutes, minutes, hours, hours. I'm left with yards per day. So if you go back and do those 2 quick steps to read your conversion factors to yourself, make sure they're logical, and then go back and cancel your units, you'll catch a lot of your mistakes here. Then I had 2 significant digits in the problem, 2 significant digits in my answer. Notice I don't care about the number of significant digits in the conversion factors because those aren't considered here. So now let's try one that's a little more difficult. Let's do, we'll just say 15, we'll say feet per second, and I want to convert that to inches per minute. So that's a little bit different. I convert the numerator and the denominator here. So let's go ahead and set it up and look at it. So I have 15 feet. Again, before I even know what I'm doing, I can write it down correctly to start. 15 feet over seconds. You don't have to know anything to do that. Just copy the problem down and you're in the right track. Now at this point you have 2 options. You can handle the denominator first or the numerator first. I tend to handle the numerator first, but whatever you want to do, you'll get the same answer. So let's go ahead and drop feet down here. So I want to convert feet to inches. Okay. So then I'm good. So we can go ahead and write this in and cross it out. There are 12 inches in 1 foot. So I can cancel feet and feet. So I'm left with inches. Now I need to cancel seconds though. So I put seconds on top and I need minutes on bottom. So there are 60 seconds in 1 minute. So I'll go ahead and show you the other option. You could do 15 feet over seconds. You could say there are 60 seconds in 1 minute, and there are 12 inches in 1 foot. Okay? Either way, the same units are going to cancel out. Okay? So both times you're going to be left with inches over minutes, inches over minutes. And 12 times 60 is the same thing as 60 times 12. So either way you get the same answer. 15 times 12 times 60. With two significant digits, you get about 11,000 inches per minute. And here you obviously get the same thing, 11,000 inches per minute. So let's go ahead and do one more together, then I'll give you one to try on your own. So let's say I have, we'll just say 25, and I'll go ahead and write it out, miles over hours. So MPH is how we see that in America, miles per hour. And I want to convert that to feet per second. Okay? So I start off with 25 miles over hours. Go ahead and draw my little box out. Again, I like to handle the top first, whatever you want to do, the same answer. I drop miles down here. Now I need to go from miles to feet. I can do that. I know that conversion factor. Then I want to handle hours. I'll go from hours to minutes. Then I'll go from minutes to seconds. Put my conversion factors in. There are 5,200. Sorry, I messed that up. There are 5,280 feet in 1 mile. There are 60 minutes in 1 hour. And there are 60 seconds in 1 minute. So go and type this in the calculator. 25 times 5,280, and then you'll divide that by 60 times 60. Okay, so we type that in, you should get 37 feet per second. And when I typed in the calculator, I got this number, but I rounded it off to two significant digits because my original problem had two significant digits. So if you didn't get that answer, go back in and figure out what you need to do in your calculator to get that answer correct. Personally, this is how I type it in when I'm doing it. So I do parenthesis 25 times 5,280 divided by 60 times 60. Okay, there are multiple ways to type that in the calculator and get the correct answer. Just make sure you know your calculator and how to get that answer correct. So I'll go ahead and give you one more to try on your own, one of the more difficult problems. So let's do 75 miles per hour, and I want to convert that to, let's say, yards. We'll say yards per second. And hopefully you know there are 3 yards in 1 foot. There are 5,280 feet in 1 mile. So go ahead and pause the video and try that conversion on your own. If you get this one right, I'd say you're in good shape to move forward. Okay, so hopefully when you typed it in, you got about 37 yards per second. So you got 36.6 repeating, and then you rounded to two significant digits. So let's go ahead and talk through it. I started off with 75 miles per hour. I chose to handle the miles first, so I dropped miles to the bottom, converted from miles to feet. Then I dropped the feet down to the bottom, converted from feet to yards. Then I'm good on top. I can go and check my units. Miles cancels miles, feet cancels feet. I'm left with yards on top. So then I cancel my my hours. Hours goes on top. There's 1 hour and 60 minutes. Minutes cancels minutes. I'm left with yards per second, so I'm good there. But then I'm going to take the extra 10 seconds and go back and read the conversion factors to myself. 1 minute, 60 seconds, 1 hour, 60 minutes, 1 yard is 3 feet, 5,280 feet is in 1 mile. It's easy to flip those conversion factors. That's an easy mistake to make. But if you read it to yourself, you'll catch a lot of those mistakes. So hopefully the process is not too difficult. We'll get plenty of practice doing it. And I know, again, you're thinking, why in the world are we doing this? I didn't take chemistry to convert from miles per hour to meters per second. But it's easier to learn this process now doing simpler problems than it is to learn this process when we're doing more complex problems later on in the spring. So if you don't like this process, I apologize. Dimensional analysis is here to stay. Even if you can do these problems in your head or in your calculator, You won't get points unless you show work doing it like this. I'm teaching you this now not so you can convert from miles per hour to meters per second later in your life. I'm teaching you this now to make your life easier when you learn actual chemistry in a few months.